In this lesson, we're going to focus on being able to write a linear equation from the table and put it into slope-intercept form. Really, all we're going to do is use really all prior knowledge of what we've learned so far. So, for example, here, the first thing I want to do is find the slope from any two ordered pairs from the table. And I got to remember, it's y over x, or the change in the y over the change in the x. So I'm going to look at my rate of change, and I see from 50 to 100, because I'm just going to choose the first two, and I have a rate of change of plus 50. And then I look at my x, 0 to 1, well, that would be plus 1. So I have actually 50 over 1, so my slope is going to be equal to 50. Now, and the next thing I want to do is I want to look for an x value of 0, because whatever my y value is with the 0 is going to be my y-intercept. It's where the line crosses the y-axis. So in this case, I'm going to look and I see 0 here for the x, and I also see 50 here for the y. So I know my y-intercept is going to equal 50. Now, not very often do you see it to where the slope and the y-intercept is the same thing. That just happens to be a coincidence here. So now, I found my slope. I was able to identify my y-intercept. Now, I just put the equation together of y equals 50x plus 50, because I have my slope, y equals m, which is my slope, times the x, and in this case, plus 50. Alright, so now in this case, it's going to be just a little bit different, because you notice the actual y-intercept isn't really visible. So we're going to have to find out how we can find the y-intercept. There's actually a couple different ways we can do it, but a lot of the steps are still the same. So for example, here, I want to write an equation in slope-intercept form from the current table. Well, the first thing I want to do is still the exact same thing. I'm going to find the slope, and again, I can choose any two ordered pairs, but I'm just going to stick to the first two. And so, for example, here, find this. I'm going to go with 140 to 160. My rate of change would be plus 20, and then over the x, 1 to 2. I'm going to add 1 because there's one difference. Well, my y over x, so I'll go y over x, and I'm going to get 20 over 1. So I know my slope is going to be equal to 20. Now, here's where it's just a little bit different. A couple different ways. I know one way I can look at the pattern and go back and say, okay, if my rate of change, I'm adding 1, and I need to get an x value of 0. In this case, it's the next one, so I could go back 1, and I could get 0. And then my rate of change for my y was adding 20, so I kind of go backwards, and so I'm going to get 120, and I know my y-intercept is going to be 120. But if I don't do it that way, or if the numbers are several numbers apart, I want to actually, all I'm going to do is substitute in what I know and solve for what I don't know. Let me show you what I mean by that. So use the slope in any point from the table. So I'm going to just simply say, okay, I have the y value. I know, for example, I'm going to choose the very first one. I'm going to choose this pair right here. And I say the y, which is 140, equals, that's the same thing as saying y, I'm going to put it underneath, equals, well, I know my slope is 20, so I know it's going to be 20 times, now, that pair that I chose, and the x value is 1. So I'm going to put, all I'm going to do is take the 1 and put it in there, and then plus b, because I don't know what the y-intercept is. So now all I'm doing is simply going to solve this equation. So I have 140, I'm going to take 140 equals 20 times 1 is 20 plus b. So now when I solve this, it's really just a one-step equation, and I'm getting b by itself, so it means I've got to subtract 20 because that's a positive 20, and I'm going to use my inverse operations. So now 140 minus 20, you have 120. That zeroes out, equals b. So now I know my y-intercept is going to be 120. So when I write my equation, I can say y equals 20x plus 120. And I had just solved for the y-intercept. and that is how you actually write a linear equation from a table in slope-intercept form.